Retrograde motion is the apparent clockwise motion of a less massive celestial object, such as a planet, orbiting counterclockwise around a massive celestial object, such as a star, as viewed from another less massive celestial object, such as a planet, that is orbiting closer to the host star. This is a large definition, so let's unpack it. Here we have on the right-hand side an animation. We're looking at Mars as it's making its orbit around the sun. In a portion of its orbit as it goes around the sun, it appears to go backwards or clockwise. Notice it's going to the right or clockwise before it continues on its counterclockwise orbit around the sun. This apparent motion backwards is what we mean by retrograde motion. It is an apparent motion. It is not a true motion. It is an apparent motion. And the motion is opposite to the direction of the orbit. So it's clockwise as opposed to the orbiting counterclockwise motion of the planet. Here on the left-hand side is another animation. And in this animation, we are looking at the three objects in the animation of Mars' retrograde motion around in the sky. The sun is at the center in the left image, and it's colored yellow. The blue Earth is in its orbit around the sun, and outside of Earth's orbit is the red orbit of Mars. Mars is going slower because Keplerian motion tells us that the further the object is from the host star, the slower it moves. On the right-hand side, we're taking a look at the animation as seen from Earth. So you'll see blue is the dot in the center, and from our point of view from the Earth, it looks like the sun is going around us. Also, we can see Mars in its orbit around us as well. And in Mars's counterclockwise orbit around the sun, it has this apparent clockwise motion there before continuing in its counterclockwise motion around the sun. This little loop is what we're talking about. Now, how this loop occurs is when we have a situation where we have the Earth that is approaching Mars in its orbit. When we have the motion of the faster Earth approaching the slower moving of Mars, we have the start of our apparent retrograde motion. So here we have Mars in its counterclockwise orbit, and as Earth approaches Mars in its counterclockwise orbit, we're going to see that Mars will not line up. If we continue on, we will see that Earth will start to go forward in the orbit, and it travels faster. And so when we're looking at Mars, it'll look like Mars is going backwards relative to our faster motion of the Earth going forwards in its orbit. So let's take a look at this. Here we start the motion, and as we can see, when Earth approaches, it looks like from our point of view, the slower moving Mars is going backwards. It's all a relative motion of the inside orbit relative to the outside orbit. The same thing happens if you're in the left lane or the fast lane and you're passing a car in the right lane. If you're not looking directly at the road, it may seem to you that both cars are going roughly the same speed, but the car in the slow lane is going slightly slower, so it might seem to you like they're moving backwards relative to your motion going faster forwards.